Okay, this is going to be fun trying to do a video with no voice. We are not going to do any warm-up exercises. We are going to now be graphing inequalities in two variables. So we've been doing inequalities with one variable, and now we're going to do them just like equations with two variables, like functions. So let's just start with our first example, finding a solution. It says, which ordered pair is not a solution of x minus 3y is less than or equal to 6? So we have these four choices, and the solution will be to just substitute the values into the inequality to check whether each ordered pair is a solution. So let's put the 0 and 0 in for x. Remember, this is our x, and this is our y. So put 0 in for x, 0 in for y, and we get 0 minus 3 times 0, which is 0, is less than or equal to 6. And 0 is less than or equal to 6. That one is true. So this one is a solution, but let's just be safe and check our other ones. So let's put 6 in for x. Can we get 6 minus 3 times a negative 1 is less than or equal to 6. Well, this would end up being 6 plus 3, which is 9, and 9 is not less than or equal to 6. And the reason we are doing this is because as we graph these inequalities down here, you're going to want to choose a point and check and make sure that you've shaded in the correct way. And you're going to choose a point and substitute it back into the inequality to check it. So let's check the next one. Let's check 10 and 3. So let's put 10 in for x, and then 3 in for y. 3 times 3 is 9, so 10 minus 9. Oh, we're looking for the one that's not a solution. Wait, I need to pay attention. So this one is a solution. 10 minus 9 is less than or equal to 6, and 1 is less than or equal to 6. So this one's a solution. And then negative 1 minus 3 times 2, which 3 times 2 is 6, so negative 1 minus 6 is negative 7. And negative 7 is also less than or equal to 6. So the one that is not a solution would be this one right here. Okay. All right. So guided practice. If you want to try that, go ahead. You can stop the video and try the guided practice. Bring that to class. I'm not going to do it with you on the video. So let's see if I can get this paper to move down. I need to scroll oh, there it is. Okay, sorry. Notes down. Okay, graphing a linear inequality in two variables. So let's look at these in two variables. It says graph the inequality y is greater than 4x minus 3. And it says first, graph the equation y equals 4x minus 3. And the reason we do this is to graph the boundary line. So we're actually going to graph the boundary line of our solution set. So this equation is in slope-intercept. It's also kind of in slope-intercept here. So if you want to just imagine the equal sign there, let's graph this line. So our y-intercept is negative 3 since it's in slope-intercept. So we're going to go down to negative 3 on the y-axis. Our slope is 4 over 1. So from our y-intercept, we're going to go up 4 and to the right 1. Okay, so now we've gone up 4 and over 1. So next thing we do is we look at the inequality symbol, and it's greater than and not equal to. So we will graph a dashed line. So you're going to graph just kind of a dashed line, or as I do, a dashed squiggle, because I'm not very good at lines. Okay, let's try this again. Let's go to negative 3, up 4 over 1, and let's just draw a line. Then I will dash it. Let's see if I can do some dashing. Okay, forget it. All right, there it's done. So this is my dashed line. If it was greater than or equal to, it would be a solid line. This dashed line tells you that we are not including any of the points on the line. Okay, and it says test a point on the line. Always choose 0, 0 if you can. You can always choose it to see if it works or doesn't work. But let's test 0, 0. So let's put in 0 for y, and then 0 for x, and 4 times 0 is 0, and 0 minus 3 is negative 3, and then 0 is greater than negative 3, so we're going to shade above the line. So you're going to shade everything on your graph. And you can just do lines like this if you want, straight lines above the graph. Now, there is a hint. If it's in slope-intercept form, like this, and it's y is greater than, then you pick all the values where y is above that line. If it's less than, it would be all the y values below that line. Okay, no matter which way it's going, it's either above the line or below the line. If it's in the form y is greater than or less than, if it's in slope-intercept form. So the shading shows that all of the points on this side of the graph are solutions to this inequality, and none of the points on this side of the graph are solutions. Okay? All right, let's look at example 3. This one is not in slope-intercept form, so let's get it into slope-intercept form first. We need to get 2y by itself, so we subtract x from both sides. So we have 2y is less than or equal to negative x. Let's divide both sides by 2 to get y by itself. So we divide by 2. Sorry about the dot above the y, that's nothing. So we end up with y is less than or equal to, there's an understood 1 right there, so it's a negative 1/2 x. What is my y-intercept for graphing at this point? My y-intercept is 0 because there's nothing out here. So I'm going to go to 0 on the y-axis. My slope is negative 1 over 2. So I'm going to go down 1 and to the right 2 and graph a point. Or I can go up 1 and to the left 2 and graph another point. Since my inequality is less than or equal to, it's a solid line. So draw a solid line along your graph, and it does need to be pretty much the length of the graph because you're going to shade the whole thing. It's less than, its y is less than, so I'm going to shade below the line. Okay, so let's test a point below the line, or let's test not 0, 0, because that one should work. Let's test like negative 1, 0. So let's test this one. So put in negative 1 for x and 0 for y. 2 times 0 is 0, and negative 1 is less than or equal to 0, so we shaded the correct area. Okay, stop the video and do your guided practice. Remember, it's greater than or equal to. Get it into slope-intercept form. You may talk to your neighbors, but that's supposed to be an arrow. Greater than or equal to. So you're going to shade above your line when you shade. It's going to be a solid line. So go ahead and pause the video and complete your graphing for the guided practice. Okay, all right, so moving on to these last couple of examples. These are those wonderful ones that that we struggle with sometimes. Graph the inequality y is greater than or equal to negative 3. So we're going to first of all graph the line y is equal to negative 3. So we're going to go down to negative 3, and we're going to graph this line. Since it's greater than or equal to, it's a solid line. Okay, and obviously we're going to graph or shade all of the points that are greater than negative 3. So obviously we're going to be shading above the line. So there is our solution set. All the points above y equals negative 3. Okay, we can try 0, 0. 0 is greater than or equal to negative 3, and it works. Same thing with this over here. We're going to graph the line x is equal to negative 1. So we're going to go to negative 1 on the x-axis, and we're going to graph the line where all the points are x equals negative 1, no matter what the y value is. And we're going to, oh, it should be dashed. My bad. So we're going to go to negative 1, and we're going to create a dashed line since it's just less than. So there's our dashed line. And where on the graph would x be less than negative 1? Obviously to the left, where it gets smaller as we go to the left. Okay. So that's that graph.